Hello everyone, this is Harry Gill. Welcome to Java. This presentation is the chapter 1 of OCP Java SC 11 Complete Study Guide by Jeannie and Scott. Let's look into the major components of Java, and let's start with JDK. So JDK is a Java development kit. This kit has multiple programs, and we are discussing 4 of them in this slide. To start with, we have Java C program. So this is used to compile the code which we write in the file. We'll see a little bit more on Java C later. Java command is used to launch the program. So it starts the JVM, which is the Java virtual machine. Java virtual machine is the program that runs the code. The third command is jar. So this is used to package multiple files into one file, and this file is called jar file. Jar is a shorthand of Java archive. We will see in further tutorials that we can use jar file to execute our program. The fourth one is Java doc. Java doc is used to create the documentation of the comments that are written in the Java program. Let's look into the complete end-to-end flow from where we write the program until we run it. To start with, we would write a program into a .java file into our text editor. We can use any text editor. We would write a program in there. The first half of the file can be anything, but it has to have extension .java. So that file is given an input to Java C command. Java C takes the input from the file that we just wrote and converts it into a format that is understandable by the JVM, which would run the program. So this format is called bytecode. In Java, this is an auto-generated file, and its name has an extension of .class. And that .class is now fed into the Java program, which starts the JVM. So JVM reads this bytecode and runs the program. If you are already familiar with the previous versions of Java, or when doing an online study, you might come across a word called JRE. It is used to create the runtime environment and run the program, but unlike JDK, it cannot compile the program. So if from Java 11, JRE is now gone, so we will always use JDK to run the program. So let's look into how does the Java class look like. So Java class have 2 primary elements. It has methods and it has fields. So methods in other languages are also called as functions and procedures, and fields are the variable. So fields are where we store the state of the object, and methods will use that state to perform some functionality. Both of them combined are called members of the class. So here is the bare minimum structure, a very simple structure of a class. We will see all the elements word by word. Before we do that, just wanted to let you know that in Java there are certain words that are reserved, and there are some restrictions that we can use those words or not. So these words are called keywords, and I'll explain you as we go in the tutorial. I'll explain you what each keyword mean, and as you progress, you will actually get hand of what are the keywords and what are not keywords. So it will be very second nature when you actually do the coding. Let's go word by word. So the very first letter, public. So public is a keyword that is called the access modifier. We will learn a lot more about access modifier in the later chapters, but for now, just think of it as public means it's publicly available. The second keyword, class. So class is used to, so in here we are telling Java that we are creating a class. And the third keyword, animal, is the name of the class. So this animal, this name can be anything of our choice. Usually we keep it a logically sound name so that when we it's more readable. We can name it anything. We can have it ABC, but usually we name it such that it represents what the class really is. And then we have an open curly braces and close curly braces, and all our code would go within these open and close curly braces for this class. This class is pretty empty, so let's add some fields and methods to make it a bit more realistic class. So in this example, I have added a field called name and its type is string. So string tells that this variable name will contain a sequence of characters. So next up, let's create a method called getName. So this method will return the name of the animal, which we just defined in the class. Let's also define a set name where we can pass in the name of the animal, and then that variable will be assigned to the new value. While we are at it, let's also see how we do the comments in Java. So Java can do a single line comments and a multi-line comments. A single line comment would start with the double slash, and then it can follow with any string or comments that you want to write. Let's also add a multi-line comment. So multi-line comment would start with the slash star and end with the star slash, and anything that goes in between can span in multiple lines. So the comments are used to tell the compiler to ignore those lines of code and compile the rest of the program. Now that we have the code written, we will save the code into a file. In Java, the name of the file in which we save the code matters. If it's a public class, the name of the file has to exactly match the name of the class. In this example, the name of the class is animal and it's also public. So the name of the file in which we store the code will have to be named as animal.java. Note that the case also matters. So we cannot write animal with a small a as a file name. It has to be exactly same as the class name. So we have a class now and we want to run it. To run this class or any Java program, we need an entry point from where the Java code will begin. This entry point is also called as main method. The rules to create the main methods are a bit strict. Let's take a look how the main method is written. As it's a method, it will be written in a class. In this example, let's put the main method in a class named zoo. The rules to create main method are, it has to start with public, followed by the keyword static, and then void, and the name of the method has to be main. The method will take a string array as argument. We will look into each keyword in the later tutorials. For now, just memorize how the main method will look like. There is some flexibility on how string array can be declared, but to keep things simple, let's use how it's written on the slide. As mentioned before, since zoo class is public, the code that we write will go in the file named zoo.java. Now that we have a basic understanding of the structure of the class, let's write some code. To compile and run Java on your system, you will need to download and install the JDK package. If you already have Java 11 installed, you can skip this section, but if you have not, just follow along. There are several ways to install JDK. However, I have found that manually downloading and extracting the tar or zip file is the easiest way to install. That way you know where exactly you have put Java. To do so, go to your browser and search for download JDK 11 Oracle. Click on the link from oracle.com. Scroll down and find the tar.zz file for your system. I use Mac. So I will download the OS X version. If you use Windows, you can download the .zip package. You will have to create an account if you don't already have one. I have already downloaded the package, so I will skip the downloading again. And once the download has been finished, you can follow along this video. Once it's downloaded, extract the content of the package. If you're using Mac or Linux, open up the terminal, go to the download directory, run the command tar-xvf and the package name and hit enter. For Windows, you can right click on the zip file and extract the contents. Once extracted, go to the terminal on Mac or Linux or command prompt on Windows and navigate to the bin directory. On Mac, the bin directory is under contents/home. This directory will have all the binary programs that we need to do various tasks in Java, including compilation of the program and also the running. While we are here, let's run the Java command and check the version. So type /java-version. If you are using Mac, it might ask you permission to run, since this is the first time we are running this command in the newly downloaded package, but going forward it wouldn't ask. If everything is good, you should see the version number. Now let's move this directory out of download into a bit more permanent location. You can keep this directory anywhere you like, but I usually keep all my Java versions in the same directory on my system. So I will move this JDK directory into /library/java/Java virtual machines. Note that you may not have this directory on your systems. So if you wish to use it, just create a new directory and then move the JDK directory into this newly created directory. Once the directory is moved, next step is to tell your system where it can find when we run the JDK commands. So it needs to know where the JDK commands live. For that, we will set the Java_home environment variable. In Linux-based systems, we set it in the bash profile. I use Z shell on my terminal, so I will set it into .zshrc located in my home directory. On Windows, I believe you will have to set Java_home and also path environment variable. So search edit environment variables and add these two variables along with the path where you have copied the JDK directory. Once set, on Mac or Linux, source your bash profile to take effect, or you can simply open a new terminal. Once done, then run the Java version command to confirm the installation is complete. If you see the version, it means the installation is complete and then you can move forward. If you see any error such as command not found, it means that the installation is not successful. Please post the error in the comments. I can help you with the solution, or search the error on Google. You will find a lot of solutions already. Now that our installation is complete, let's write the Java program. I will create a new directory called chapter_1 and put all my code in there. To write a Java program, I will use VI editor, but you can use any text editor that you are comfortable with. Java doesn't care how you write a program until its syntax is correct. As we have seen in the slides, let's first create an animal class. Now that we have a bare minimum class, now let's add variables and methods to the class. While we're at it, for completion, let's also add some comments, a single line comment and a multi-line comment. So if I list the content of the directory, you will see I have created animal.java file. Just reiterating again that the name of the file has to match the name of the class since it's public. Next up, let's create an entry point so that we can use the class. As mentioned, any Java program needs to have an entry point to start, and then thereon we can use different classes to do different things. For this, I will name the class as zoo. So we'll write the code in zoo.java file. Now that we have a bare minimum zoo class, let's compile it. To compile the code, we will use javac command. So it's javac space zoo.java. Hit enter. If you do not see any message, that means we have compiled the code just fine. If you see any error, please make sure the code of zoo.java is exactly same what I have written. Now if I list the content of the directory, you will notice that javac have created a new file called zoo.class file. This class file contains the bytecode that the Java understands how to execute. Let's open the class file and see the content. It's a binary content. We wouldn't understand anything, but Java knows how to understand. So we don't really need to open or edit the Java class. So we always edit the .java file, and then we do a compile, we create a bytecode, and we run the bytecode. So to run the program, we will use the Java command. So it's java space zoo. Note that we did not give the extension .class. It's because Java already knows that it needs to run a class called zoo. So it finds the .class on its own and hit enter. We will not see any output since we did not write any code in our main method. Let's put a print statement so that when we run the program, we know that it's successfully executed. So open the zoo.java file, and inside main method, let's put this line: system.out.print braces and then semicolon to end the statement, and let's add double quotes, welcome. Let's add ln at the end of the print so that it prints a new line after the word welcome. Save and exit the file. Since we have changed the code in zoo.java file, we will have to recompile it again to create the updated class file. So let's compile it with the javac command. Now let's run it. As you notice, we have the welcome printed. This is the code that we wrote in the main method. We have not used the animal class anywhere yet. We will do it in the next tutorials. But for completeness, let's compile the animal class and see what happens. So as you see, after compiling the animal.java, it creates an animal.class file. We will use animal class in future tutorials once we get to the point on how to create instances out of class. But for now, just note that every Java file will have a corresponding .class file which will contain the bytecode. This concludes the tutorial. If you have any comments, good or bad, please post the comments in the section below so that I can improve my future videos. Please hit subscribe button and the bell icon so that you can get notified for my future OCP certification videos. I will see you in the next one. Until then, bye.